point, and then I'm going to put a point at the origin to indicate that that is my center of enlargement. Next, I'm going to go to the transformation tool. Now, if you look right there, you'll notice that you're not seeing enlargement. What you'll see is dilate from a point. So that is what we want to select, dilate from a point. So I'm going to dilate from a point, and then I'm going to select the object, select the point, and then where it says factor, I can indicate what I want my scale factor to be, whether I want it to be negative, positive, or I want it to be a number that is less than 1. So you can indicate what the scale factor will be. So I want my scale factor to be -2. So I just put in the scale factor -2 and click OK. And all I'm seeing there is a line segment. It means that the entire polygon was not selected. So I'm going to have to undo, press undo, and I'll have to go again. So I'm going to go back to my transformation tool. I'll select dilate from a point, select the polygon. Notice that the entire polygon is now selected. Select the point. I'm prompted to give the scale factor. I'm going to type -2. Sorry. That should be -2, and then OK. And there I have it. My triangle ABC was enlarged using the scale factor -2, and it was enlarged using the origin as the center of enlargement. And it's pretty much the same regardless of the scale factor that you're using. The steps are pretty much the same. So if you want the scale factor to be less than 1 or greater than 1, or if you want it to be negative, the process is still the same. So this is how we can use the GeoGebra software in order to perform transformations. And this is a helpful tool to get the students to self-check their work. So if they're working on something, they're not sure whether or not their answer is correct, and you're not there to give them an immediate feedback, they can always use the GeoGebra software to check their response to see whether or not they are correct. Thank you so much for watching, teachers.
So in the other video that we're about to view shortly, the focus is on the association of the matrices with the transformation. So in this video, we'll be looking particularly at enlargements, but you can encourage your students to try other transformation. Once the activity is created where you insert the matrix equation into the window itself, then the students can observe the change between the matrices and the transformation that is being done. So let's take a look. In this video, we will be exploring the 2x2 matrix associated with enlargements at the origin or center. To explore this concept, you may need to develop your own manipulative or activity using GeoGebra. Please note, you may select either the navigation bar or construction protocol under the view options in the main menu for details how to recreate this activity. Let us go ahead and show you where those are located. All right, so your main menu is in the upper right-hand corner of your window. Your protocol, construction protocol, once selected, will give you details about the objects and their associated properties. The navigation bar, which is located to the base of your window, will give step-by-step procedure or playback to show you how the activity was constructed. All right, so once we know how to do that, the next thing is for us to encourage students to explore using the activity. But let us look firstly at how this activity can help our students. All right, the activity should help students to see the relationship between scalar factor, transformation matrix, the object, and its image. The manipulators should be able to address misconceptions or errors related to the followings. 1, enlargement involving negative and fractional scale factors. Enlargements involving positive and negative scale factors. And finally, to help students to associate the correct transformation matrix with its respective object and image. You should encourage your students to resize and reposition the object. Then to use the slider to make changes to the scale factor. Let us go ahead and demonstrate how that is done. So right now I am going to reshape and reposition my object. And I will be changing the scalar factor using my slider. Encourage students to look at scalar factors that are positive, those that are negative, and those that are between 0 and 1. To observe the changes in the transformation matrix as well as the image. This activity is fairly easy to recreate in GeoGebra. And once you have created that activity, your students will be, it will be accessible to your students. It's very easy to use, and you can also share it via the internet. Thank you for watching. All right, so we are going to be introducing you to another manipulative that could be used. It's actually an applet that you can find online at this particular website. It demonstrates all of the transformation matrix related to different transformations. We only demonstrated today the enlargement, but if you visit this website, you'll be able to find all the others related to the transformation matrix and their associated transformation matrix. So we encourage you to take a screenshot and give the website a visit. At this time, I'm going to hand over to Mrs. Simpson. Thank you.
Okay, thank you again, Judith. Now at this time, we want to look at circle theorems virtually. Now, for this section of the presentation, we want to focus on 2 of the objectives thus found in the section 8 of the CSEC syllabus. So we're looking at solving geometric problems using the properties of circles and the circle theorems and determining and justifying angles using circle theorems. Now, of course, the students would have come to us with prior knowledge, and most of these knowledge would have been obtained from as low as grade 7 and 8. Now, by the time they reach a grade 9, all of the objectives would have been covered for the prerequisites. And so some of these prerequisites include properties and parts of the circle, understanding and using alternate and corresponding angles on parallel lines, derive and use the sum of angles in a triangle, measuring line segments and angles in geometric figures, including interpreting maps and scale drawings. And so for the set of objectives in the desired state, we will have no objective in the gap. Because as I said before, they would have covered all of these by the time they reach grade 9, term 1. Now let us look at a sample of a student work under this concept. So I want you to do the diagram. Examine the diagram thus found, and it's a sample CSEC question. And I want you to think about what error misconceptions the student likely make as they would have been computing the missing angles. So let me give you at least 1 minute to look at this diagram and share with what misconceptions you think the student would have. All right, so we see in this diagram that there is a quadrilateral. There are two quadrilaterals, to be specific. We have quadrilateral ABCD, and we have quadrilateral AOCD. Of course, the misconception would be to think that quadrilateral AOCD would represent a cyclic quad. And of course, they would apply the properties of cyclic quad to that quadrilateral. Now, here I want to share with you some other misconceptions or errors as it relates to circle theorem. And so I have them looking at imprecise definition of angles and properties, and the use of incomplete or unrelated angle properties to justify or support their solution. So for example, they are given a problem that involves a triangle. And of course, they are simply saying that the sum of the angles in a triangle is 180 degrees. But what if the triangle was isosceles? And so they would have to be very specific to state that. Also, they would look at the misuse or misinterpretation or interchange angles and line notations. Now, I want to share with you a video that seeks to demonstrate how we can set up our virtual worksheets to assist our students in exploring the circle theorems. So let's look at this video.
Hello, everyone. I have found this website, www.transom.org, to be a very useful website as it relates to circle theorems. As we scroll down, we can see that there are pages related to circle theorem proofs. There's a game related to circle theorem pairs. There is circle theorem worksheet and circle theorem exercises. If we look briefly at the circle theorems proofs, so here in the circle theorems proof, we have the various theorems on your left and the related proofs on the right. And that goes on for each of the circle theorems. So of course, this is very useful for students to be able to explore and to see how the sizes of the various angles within the circle can be found. There's also help videos, more about circles, and more about angles. In the circle theorem gaming section, what we have are circle theorem pairs. And in this pairs game, there are several. There are at least 5 games on this page. We're going to look at the circle theorem pairs game. In the circle theorem pairs game, you will select as you just select one item. So it says angle in a semicircle is a right angle. And then you're going to be searching, you're going to do another selection. And if they match, then that would be a correct response. So they did not match. And so you will not know what item is there, but it's also a memory game, because then you will have to remember where you saw something that would relate to this new tile that you have selected. So students will have to be careful and remember the theorems to be able to make those associations. So I'm thinking now that this first tile, along with this last tile in that first row, would work together. And so there we have a winner. So this is a very useful website that you can explore with your students as it relates to circle theorems. Thank you.
So in our next video, we want to show you how we can use GeoGebra now to set up or model our circle theorems.
1, Today, we will demonstrate how the website www.geogebra.org can be used to prove circle theorems. To the left of your screen is your panel. In your panel, you have the basic tools with which you will work. For this activity, we will use mainly the Circle tab along with the Measure and Lines tab. To begin, we will go to our Circles tab and select Circle, Center, and Radius. We will click and also click in our workspace. Here, we will be prompted to enter a radius for the circle we wish to construct. I will enter 3 units. Now that we have our circle, let's insert our line segments. From our Lines tab, we will select Segment. Once that is selected, I'm going to be placing this line segment from one point on the circumference to the other point on the circumference, passing through the center of the circle. Then I will select 2 other line segments that will come together to form an angle at the circumference of the circle. Now I will go ahead and select my angle tool from my Measure tab. Hello everyone.
We would have shared with you some of the videos in which we were able to set up our worksheets using GeoGebra. I want to share this other website that I found in which we can send our students to explore the theorems. And so I invite you to take a snapshot of the screen and you can visit as soon as we end today. Now, before we go, and we're almost at the end of this webinar, before we go, I would like to share with you some tips on managing the virtual learning environment. Now, the first thing I'd like to say is that ensure that all your in your classroom, your virtual classroom, is organized. Ensure that the students have easy access to the materials and resources that you have in your classroom. We also want to emphasize engagement in all the sessions. So ensure that whole group sessions are short, no longer than 10 to 20 minutes. And of course, use this time to prepare students for hands-on activities and clarify misconceptions. Of course, you can even convert some of these materials that we use in real-time session for asynchronous student consumption. Also, we want to encourage you to solicit regular feedback from your students. Use annotations and interjections to scaffold the learning. Ensure that for formative assessment, we use low-stake interactive quizzes that easily provide feedback to students on their progression. And of course, if you're going to be using technology, ensure that beforehand you test the technology to ensure a smooth delivery. Now, involve your students in creating norms for the class. Set times for synchronous and asynchronous sessions. Connect with the students as often as you can to reduce the risk of them feeling isolated. And of course, this final tip I want to share with you. Take care of yourself first. Your physical and psychosocial health is of prior importance. Recharge your body and brain. And I want to end this webinar by leaving you with a quote, an anonymous quote, and it states, "Life is a math equation. In order to gain the most, you have to know how to convert the negatives into positive." Thank you for sharing with us this afternoon.
Thank you for attending today's webinar on using virtual manipulatives. If you have any other questions, please contact any of our 7 regional coordinators. Once you leave today's webinar, you'll receive an evaluation form for the presentation. Now, it is important that we know how you felt about the webinar, so please complete so we can see your feedback. You will also receive a follow-up email within 24 to 48 hours with a link to view a recording of today's webinar. On behalf of the National Mathematics team and our presenters, thank you for joining us today and have a great weekend.